Good morning, students. This is Professor Sagar Birje, HOD of Computer Science Department. On behalf of Department of Computer Science and Engineering and all my faculty members, I welcome all my third semester students to my department. Once again, I welcome you all. Hope I am already known to you people. I have handled C programming subject for you in second semester, and in this third semester I will be dealing with the subject analog and digital electronics. So the subject code for this subject is 18 CS 33. So this is the third subject that you will be learning, and it actually deals with the analog and digital electronic concepts. Fine. So this subject you can relate with the basic electronic subject that already you people have studied it in second semester. So the basic of electronics already has been covered in second semester. So some of the advanced concepts regarding basic electronics are going to be discussed in your analog and digital electronic subject. So the textbook that you are going to refer is the Charles Swan and Larry King. Okay, the subject textbook title is your analog and digital electronics, and the publisher is Changing Learning. 2019 is the edition that you need to refer. So these textbooks are already available in library. You can get it from the library. Fine. Apart from that, there are some reference textbooks that you also need to refer in order to understand the concepts in a better way. So for digital part, you have Donald P. Leach and Malvino and Gautam Shah with the textbook title Digital Principles and Application. It's an 8th edition. Publisher is Tata McGraw-Hill, 2015 edition, and published in 2015. And we have the second textbook like Anil K. Mani and Varsha Agrawal, which covers the electronic part. So electronic device and circuits is the textbook name. Publisher is Willy. 2012 is the edition. So we have this subject with a practical approach also. So the theoretical concepts that you will be learning in this particular subject will also have a practical touch. That means this subject also has a lab. So 18 CSF 37 is the code for the lab what you are going to study. Analog and digital electronic laboratory is going to be a part of this particular subject. So whatever concept that you are going to study in this particular subject, so you also have a practical hands-on training on those concepts that you will be learning. So you can relate the theoretical concept along with the practical aspects that you will be doing it in the laboratory. Okay. So regarding the laboratory part, I will be dealing it later. First of all, let us understand the objective of learning this subject, that is analog and digital electronics. What are the basic objectives? Why I should learn analog and digital electronics? That is very, very important. Unless and until you understand the basic objective behind this subject, you will never relate this particular subject with the practical aspects of this subject in today's world. Okay, so if you look into this particular subject, that is analog and digital electronic, it has two parts covered. One is the analog part and the second one is your digital part. Okay, so the analog part covers is been covered in the first module, and the second, third, fourth and the fifth module majorly covers the digital electronic part. Okay, so let us understand what is the course objective or the course outcome of this particular subject. After learning this particular subject, that is analog and digital electronic, what I will be able to understand. Okay, that is what is the course outcome means. Ultimately, the end of the subject, what I have learned, that is what talks about the course outcome. The learning outcomes of this particular course are here the the students will be able to understand, okay, the designing and analyzing the applications of analog circuit using photo devices, the timer ICs, power supply regulator ICs, and op-amps. So these basic concepts about analog part will be covering in module number 1, and the first objective states about the learning methodology that you are going to have in module number 1. The second objective of this particular subject talks about explaining about combinational logic circuits, the simplification techniques like K-map, Quinn-McCluskey method, and Patrick methods. So these concepts you will be learning in module number 2. So the objective of the second objective, what I can say is, concentrates mainly on simplification techniques. The third course outcome, where the students will be able to understand about diodes, not the diodes, the decoders, encoders, multiplexers, adders, subtractors, working of flip-flops, designing of registers, and counters. So basic concepts about decoders, encoders, multiplexers are going to be understood by you in this particular course outcome 3. Course outcome 4 talks about working of flip-flops, different types of registers that you will be learning. Okay. And the fifth course outcome talks about designing of different types of counters, registers, and analog to digital and digital to analog converters. So these are the basic course outcomes that you are going to learn at the end of this particular course. So students will be able to understand all these 5 course outcomes once they complete this course of analog and digital electronics. Okay. So to start with the syllabus that you have, okay. Totally, as you all know, so this is a 18 scheme syllabus, and you have 5 modules. As I told, this is analog and digital electronic subject. So you have 2 parts covered in this subject. The first module talks about the analog part, which covers about photodiodes. It covers your op-amps. It covers your IC 555 timers. Module 2 talks about K-map simplification techniques. Here you are going to learn about Quinn-McCluskey method and Patrick methods in simplifying the equations. Module 3 talks about combinational design and simulations using gates. And it also talks about the multiplexer, decoders, and programmable logic device designing circuits. It also covers about the flip-flops and other synchronous and asynchronous sequential circuits. And module 5 covers about registers and counters. Okay, so these are some of the concepts that you will be learning in these 5 modules. Apart from this, as I told you, students, that we have a lab associated with this particular subject. So this laboratory, that is analog and digital electronic laboratory with the subject code 18 CSL 37, is also divided into 2 parts, that is part A and part B. In part A we have 3 experiments which basically deals with the analog part. Here you will be demonstrating the working of a stable multivibrator using IC 555 timer, and using some op-amps we are going to develop the relaxation oscillator and a design of a window comparator. Okay, so part A has 3 experiments which will be mainly focusing on module 1 concepts. Part B talks about the digital electronic circuits. Here we are going to learn, there are totally 6 experiments in part B, where you will be learning designing of half adder, full adder, half subtractor, full subtractor. You will be also learning about designing of a 8:1 multiplexer. You will be also learning about designing of a JK master slave flip flop. You will also learn about different code conversion techniques, that is binary to gray, gray to binary conversion techniques. You will be also learning about designing of the synchronous up counter techniques using JK flip flop, and also you will be implementing some of the other asynchronous counter techniques. So totally you have 9 experiments. First 3 experiments belong to the analog part, and the next 6 experiments belong to your digital part. So all these experiments will be executed and demonstrated to you, as well as you have to have a hands-on experience on this particular concept. So I wish a better learning of this subject in this particular semester, and I also request you to timely clarify the queries and the doubts that you have in this particular subject. There will be different assignments that will be given to you to test the understanding of that particular subject apart from your internal exams. Apart from that, there will be some presentations that will be scheduled so that you have some extra and better learning about these particular subjects, where basic concepts about this subject will be also discussed in those particular presentations. So hope we have a better learning, teaching learning process, and let us make this subject better one. Okay, thank you. In the next class, I'll be discussing about some of the basic concept about basically I'm going to start with respect to the second module, which covers your digital electronic part, because this is in continuation with the basic electronics that you people have already studied, and these are the concepts which are easy to understand and which will have some interest that will be created initially with this particular subject. So the next concept that I will be teaching you is about Boolean algebra, which already you people have studied, and then later on we actually start with your module 2, that is K-map simplification. So thank you for attending this class. Hope you have understood the textbook that you have to refer, okay, and how this subject is going to help you in understanding the concepts as well as the practical aspects that will be covered in the laboratory module wise that you will be learning. So thank you for attending the session. Have a nice day.